Over the next 10 years, New Zealand's digital infrastructure sector is projected to unlock roughly $70 billion in new economic activity. To capture that value, global tech giants are already moving in. Amazon Web Services and Microsoft have committed billions of dollars to build massive local cloud regions across the country. But that momentum recently hit a wall. After spending $40 million in preparation, Amazon abruptly abandoned construction on a major new data center in West Auckland. The company ran the numbers on local construction costs, but more importantly, they hit a hard physical ceiling. Auckland's urban electricity grid is highly congested, and securing large parcels of land with the massive power connections required for modern computing has become incredibly difficult. This bottleneck exists because the internet has shifted. While earlier digital systems focused on streaming and storage, modern artificial intelligence requires the active synthesis of new data, a process that requires an entirely different scale of energy. The traditional urban data center model is hitting a physical limit. To support the computing demands of the next decade, the tech industry is being forced to rethink exactly where and how it builds. In the early days of cloud computing, basic apps and streaming services were highly sensitive to network delays, known as latency. To keep those services fast, data centers had to be built inside crowded cities, as physically close to the end users as possible. This animated diagram illustrates the difference between those older applications and the new AI model. Unlike streaming a video, training massive artificial intelligence models doesn't happen in real time for the end user. It takes months of continuous calculation, meaning proximity to a population center no longer matters. Freed from the need to be near millions of smartphones, tech giants are making real estate decisions based on two different metrics: access to massive amounts of raw, continuous electricity, and natural cooling to keep the servers from overheating. To meet that energy demand, the industry has developed a new standard called Hyperscale. These are bespoke, sprawling campuses engineered from the ground up to draw hundreds of megawatts of electricity, often consuming as much power as a small city. By separating data storage from data processing, this single change in technical requirements is actively redrawing the physical infrastructure map of the country. With Auckland's grid congested and land at a premium, developers are looking south, shifting focus to the expansive, cool climate region of Southland. This shift is materialized in the Datagrid project, a massive proposed AI factory located in Invercargill. This government briefing document outlines the specifics of the proposal. Under the Hyperscale data center section, it confirms the purchase of 49 hectares in North Makarewa, explicitly stating the site is intended to facilitate intensive workloads, like training AI models. The location is highly strategic. By bypassing the urban grids of the North Island, the campus can plug directly into a regional energy pool, supported by New Zealand's 85% renewable hydro and wind generation. The document outlines the Tasman ring, a subsea cable providing 540 terabits per second to Australia by 2027, solving the remote location. It also highlights New Zealand's Tier 1 status under US rules, granting unrestricted access to advanced graphics processing units for AI. By combining stranded renewable power, a naturally cool climate that lowers cooling costs, and unrestricted hardware access, the South Island transforms from a geographic periphery into a highly competitive global AI hub. AI infrastructure allows New Zealand to take its abundant renewable energy, convert it into computing power, and export it as a valuable global digital commodity. But the capital required to build these facilities is highly mobile. As Amazon's abrupt withdrawal in West Auckland demonstrated, tech giants will quickly redirect their billions elsewhere if local infrastructure delivery fails. Scaling up requires a coordinated national strategy. Planners have to streamline complex consenting timelines while accurately assessing the environmental impacts of massive land and water use before construction begins. If those hurdles are cleared, successfully building these hubs onshore ensures that local businesses and government agencies maintain strict data sovereignty over their own AI systems, rather than relying on overseas servers. The country now faces a delicate balancing act, figuring out how to capture an unprecedented influx of foreign tech investment without accidentally overloading its domestic power grid. New Zealand's role as a remote data repository is shifting. By positioning itself at this crossroads, the country could provide the clean energy foundations required for global artificial intelligence.
Why did Amazon abruptly abandon a $40 million data center?